Hi, Algebra 1 guys. Welcome to homeschooling online video number 1. When I do these videos, I'm not going to do them for every topic, but I will try to do them for a lot of them. I will always try to reference what section in the book we're in. So if you want to go back to the book and read some more about it, you can do that. I do expect that when I'm doing these videos that you have your notebook out and that you're taking notes just as if we were in class. I still want this stuff to go in the notebook even though you're going to have a video of this. So I'm going to back up a little bit to where we were when this all happened. And we were graphing, if you recall, the last thing I had you do was graph some exponential growth functions. We talked about some things that are growing exponentially. The coronavirus, unfortunately, tuition at St. Ignatius High School, most things that are affected by inflation, you know, the price of gasoline, the price of a loaf of bread, those are all growing exponentially. Some small, slower than others, but nonetheless, they're growing exponentially. So if you recall what an exponential function looks like, is something like this. A times b to the x. The base b is always going to be a positive number. A can be a positive or a negative number. B is not going to be 1, because if b was equal to 1, 1 to any power would just be 1. That wouldn't grow at all. That wouldn't be exponential. That would be a line. So if I want to graph one, let's do an easy one. Y equals 3 to the x. I'm going to make an XY chart over here. I hope you can see, maybe I'll do it over here. I hope you can see the whole smartboard. XY. So if x is, let's start with 0. 3 to the 0 power. Anything to the 0 is 1. If x is 1, 3 to the 1 is 3. If x is 2, we're at 9. Now, I don't really want to go any higher than 2 because I'm going to be off the graph. So what happens if I go into the negatives? What's 3 to the negative 1? You haven't forgotten already, have you guys? 3 to the negative 1 is 1 over 3. Remember, a negative exponent makes something the reciprocal of what it would be if it was positive. So if x was negative 2, it would be 1, 9. So let's go ahead and graph that. It's going to go through 0, 1, 1, 3, 2, 9. See how it's shooting up there? If I go left, I'm going to be at 1/3. Then I'm going to be at 1/9. And I think we talked about the fact that you can see that this is going to get closer and closer to that x-axis, but it's never going to touch the x-axis. It's just going to become teeny tiny number and get closer and closer to 0. So this is the basic way that an exponential growth function looks like. And as this base changes, if it was 4 to the x, that would just shoot up just a little bit higher, faster, like this. Okay? And then 5 to the x would be even a little bit steeper, etc. Okay? So that's what an exponential growth function. And you did a whole sheet of those already, so I think we're pretty good on that. Now I want to take a look at exponential decay. When does something lose on an exponential way? One of the things might be a good example in real life of something that loses or decreases exponentially is the value of a car. The minute you drive a brand new car off a lot, it starts losing value. Some cars will depreciate maybe 6-7% a year. Now, that means the biggest loss is going to be in the first year, because if you buy a car that's, let's say, $30,000 and you're going to lose, let's do the math, $30,000, and you're going to lose 7%, 7% 7% is 0.07. Remember the quick way to find a percent? Because 7% is 0.07 or 7 over 100. These two zeros, knock two of those off, and we're going to get $2,100. And you're going to lose $2,100 in value off that car in the first year. Now the next year, the car isn't worth as much. So if you continue to lose 7%, 7% of a smaller amount isn't going to be as much as $2,100. So the less the car is worth, the less you're losing each year. So when do we have an exponential decay function? In an exponential growth function, if you went back and looked at the worksheet I gave you, in growth, this b is going to be greater than 1 for a growth function. I mean, just think about it. If you multiply something by 1, it doesn't change. If you want to multiply something and end up with something more, you're going to multiply it by something more than 1. So if we're talking about exponential decay, and I have $100, what am I going to multiply it by? Positive. That would get me less money. If I multiply it by anything greater than 1, like 2, I'll have $200. 3, I'll have $300. That's getting bigger. What kind of number could I multiply it by to get less? Can't be negative though. So don't say, well, -1 or -2. It's got to be positive. Did you think about it? If you said something like a half or a third or a fourth, you're right. Half of 100 is only $50. So an exponential decay function looks the same as an exponential growth function, but in a decay function, the b is some number between 0 and 1, like 1/2, 1/3, 2/3, 4/5, 0.79, whatever. So here's an example of a simple exponential, I'll use an easy one, decay problem. So I'm going to use y equals 1/2 to the x power. So b is the 1/2, it's between 0. In this problem, a is just 1. I'm making a simple one. So let's make an xy table for this one. I'm going to make it right here. So if x is 0, anything to the 0 power is 1. If x is 1, 1/2 to the 1/2 to the 1 power is just a half. If it's 2, what's 1/2 to the second power? That's 1/2 times 1/2. Don't say that's 1, that's 1/4. If it's 3, it's going to be 1/8. Well, I think I can see what's happening. I mean, if I just start graphing these, I'm at 0, 1. I'm at 1/2 when I'm at 1. I'm at 1/4. Let me make this graph just a little bit bigger here. Okay, let's start this over again. So at 0, we're at 1. At 1, we're at 1/2. Then we're at a 4th. Then we're at an 1/8. I think you can see that it's going to get smaller this way. So what happens if I go in the negatives here? Do you remember? What's 1/2 to the -1? Remember, a negative power simply gives us the reciprocal of what it would be if it was positive. So if this was positive 1, it would be 1/2. If it's -1, it's going to invert and become 2 over 1 or 2. If x is -2, 1/2 to the -2, well, 1/2 to the +2 would be 1/4. It's going to invert and become 4. So as I go into the negatives, at -1, I'm at 2. At -2, I'm at 4. At -3, I'd be up at 8. So this kind of looks just like it's going the opposite way of an exponential growth function. This is going down. The value is going down as x goes up. And it drops dramatically in the beginning and then starts to level off. You know, another good example of this, of exponential decay, is we park our car in the garage in the wintertime. And when we pull out of the garage, let's say it's 25 degrees outside. We might pull out of the garage and it'll say 40 degrees because our garage isn't heated, but gets a little bit of warmth from the house because it's attached, so it's usually warmer. Now, by the time we get to the end of the street, so when we pull right out, our car thermometer will say it's 40 degrees. By the time we get to the end of our street, which isn't that long, it might already be down to, let's say, 37 degrees. And then it keeps dropping till it starts to level off at the outside temperature, which is 25. But it drops the fastest in the beginning, and then it starts to level off as it approaches the outside temperature of 25 degrees. So this is what an exponential decay function looks like. So on your assignment, after watching this, you're going to see an assignment to do a worksheet on exponential decay. It's some graphs, and they're going to all kind of look like this. So that's your next assignment. See you soon.